Yes, physical students, let's start with lecture number 1, thermodynamics. What is thermodynamics? Thermo is related to heat, dynamics in transit, in action, fluid dynamics, liquids or gases in action when they are in motion. Thermodynamics could be precisely related to heat transfer between bodies. Students, thermodynamics, as written here, is a macroscopic science. What is the meaning of macroscopic science? What are microscopic and macroscopic variables or microscopic and macroscopic properties? Well, the answer is, let's say, this is a kind of, kind of irregular shape, some volume in which gas is there. So we all know that gas is made up of atoms or molecules. So every molecule has its own identity. In the sense, there are so many variables associated with every molecule or every atom in an element. For example, this particular molecule, if we talk about, this has its own kinetic energy. It had it has its own potential energy. It has some certain temperature, right? Now, when we talk about the variables or the properties at microscopic level, at atomic or molecular level, like lattice vibrations, number of atoms in a different structure, like we have FCC structure, BCC structure, HCP structure, like in diamonds. So this properties and this concepts and this sciences comes under the purview of macroscopic macroscopic understanding. But when we talk in terms of atomic level or molecular level, we say it's at microscopic level. So thermodynamics as such is a macroscopic science, means when heat transfer is taking place between two bodies. Let's say this is a body and there's another body which is attached with this, owing to temperature difference. Let's say this is at T1 and this is at T2. Definitely T1 should be greater than T2. So we will say the heat transfer is taking place in this direction, right? So we're not really concerned about what is happening at the microscopic level of these two substances. We're just concerned with the heat transfer or other macroscopic properties, right? Similarly, we are not concerned about the kinetic energy of atoms or molecules here. Rather, we are concerned about the kinetic energy of the whole gas, this much volume of the gas. So we are concentrated about what is happening with the whole thing, not what is happening with the atoms or molecular level. It's a macroscopic science and doesn't go into the molecular constitution of matter. Okay. Another thing, students, heat. It was really a difficult path for the physicists and other scientists to understand what is heat, what is the unit of the heat, and the present understanding that heat is a form of energy. Heat was taught in a wrong sense as an invisible fluid, which gets transferred somehow from a body at higher calorific value to a body at lower calorific value. Now, from the calorific value, now we understand that it is the they were trying to probably express things in terms of temperature. So now the more clarity of heat is there. We know that the unit of the heat is joule and it is form of the energy. It's not any unnatural or invisible fluid. Okay, let's go further. Having understood slightly what is thermodynamics, students, let us understand we normally come across this word system when we talk about different things in thermodynamics. What is this system? Okay, so students, a system is basically, if you really want to define system, it's you know what it is in your according to your subject. We will define a system as set of infinite particles constituting a particular volume, a particular mass on which your attention is focused, on which your attention is focused. So it may be a small volume of gas, big volume of gas. It may be a small piston cylinder in an engine. It may be an entire engine, or it may be an entire car, or it may be an entire city, or it may be an entire universe also. Accordingly, we will have categories of system. What are the categories of system, students? Let's see. So, system is of three types. Number one is open system. What is the open system? Students, let's say we have some enclosure in which some gas is there. So the enclosure is like this, that across the boundary of this system, every system, when you talk about a system, it has boundary. And if you want to define the boundary of the system, it is boundary is actually the hadbandi, the enclosure which is separating the system from the surroundings. What is boundary? It's something which separates the system from surrounding. So we have system and we have boundary, which decides how big, how small is the system. More interesting, students, boundary can be real and boundary can be imaginary also. Well, you might ask, how could the boundary of a system be imaginary? The answer will be, the question will be answered very shortly. So, open system is a system across the boundary of the system, both mass transfer and energy transfer is possible. How? Well, let us say uh, this is a kind of container, right? In this container, you see, let's say, now the gas, some steam is coming, or maybe some gas is coming. It's hot steam, maybe superheated steam, And let's say from here the steam is moving out. Now, if I consider this much portion, it is the ideal example of an open system because both mass is coming in, mass is going out, steam is mass of water vapor, and the energy is also coming in, energy is also going out. How? Because steam is having heat is entering the system, heat is exiting the system. Am I right? So this is an example of open system. The second system may be closed system. What is this closed system? Students, a closed system is a system in which through the boundary energy transfer is possible. But yes, anyone can add, mass transfer is not possible. A good example of closed system. Now students, third one, isolated system. What is this isolated system? Isolated system has its boundary which is totally isolated from the surroundings. Means to say, there is no mass transfer across the boundary from the surrounding to the system or from the system to the surrounding. There is no mass transfer as well as there is no, yes, Jinder Kaur? Energy transfer. Energy may be in the form of heat. It is having perfectly insulated walls. Now, in thermodynamics, this insulated walls, this insulated boundary or insulated wall is normally referred to as adiabatic wall or adiabatic boundary. Adiabatic means, I don't know what is the origin of this word adiabatic, but adiabatic means, it's 100% insulated. There's no energy transfer, there's no heat transfer. So you can say your thermos, if there's no heat transfer, could be considered as a closed bottle, closed thermos could be considered as isolated system. This is the open system. Uh, a thermos which does not have proper insulation. So there is a fluid inside a thermos, it's gradually getting cooled down. That means energy transfer is possible, right? That is a good example of closed system. Open system, mass is coming in, mass is going out, is a good example of open system. All right, students. Let's go further. Having defined system, now we want to define system with more understanding. What is state of system in thermodynamics? Normally we hear this is the state of the system. What is actually the meaning of, students? The state of the system. So students, like human being is described by its characteristics, maybe anger, maybe lust, maybe greed, whatever it is, knowledge, you know his achievements. So a system is defined by state of the system. The state of the system is basically, you know, set of variables or set of properties, thermodynamic properties. These are thermodynamic properties which define a system. What are these thermodynamic properties? Thermodynamic properties are temperature, could be pressure, could be specific volume or volume, specific volume or volume. What is specific volume? Specific volume, small v, is basically its volume divided by unit mass, specific volume. So specific volume, temperature, pressure, so many other thermodynamic properties define the state of the system. In your textbook, the individual thermodynamic properties are referred to as states of the system. But when you go for higher studies, so many properties, maybe temperature, pressure, volume, together will define the state of the system. But here in your book, slight difference. Individual properties are termed as states of the system. Means thermodynamic variables are referred to as states of the system. All right. Okay. Okay. So students, having defined state of the system, let's go further. What is that? Now we talk about what is thermal equilibrium. Okay. So, all right students, what is thermal equilibrium? Okay. So, now students, we talk about two systems, system A and system B. Now this is first case in which the system A and system B are separated by a adiabatic wall. Adiabatic wall. Students, would anyone tell me? I've just told you what is a adiabatic wall. Yes, Ishma? Amitoj? What is a adiabatic wall? Yes. No energy transfer. Perfect insulation. ठीक है? Mass transfer तो होगा ही नहीं. There's no energy transfer. There's no heat transfer also. Okay. So the heat transfer is not there. From this to this or from this to this, heat transfer is not permitted. This is adiabatic wall. And now this one is diathermic wall. Diathermic wall. What is diathermic wall? By diameter, right? This side radius, one radius this side makes it diameter. D is equal to 2R. Almost same concept. Dipole moment, diathermic. Thermodynamics, I told you, related to heat. So heat transfer is allowed or facilitated both sides, A to B, B to A, as the characteristic of a diathermic wall, both sides. So diathermic wall permits not the mass transfer, but the heat transfer, particularly heat transfer, right? So what happens in this first experiment? A and B are separated by adiabatic wall. So there must be some thermodynamic variables associated with this, like maybe PA, maybe the pressure of system A, and VA, maybe the volume of system A. Similarly, PB and VB are the thermodynamic variables of system B. Now we observe after half an hour or after 1 hour, the if this one is the adiabatic wall, adiabatic, or we say insulating wall, this whole thing. This whole thing is insulating wall. So we can say that after 1 hour or 2 hours, if it is perfect insulation, there is not going to be any change in the thermodynamic properties of the system A. That means PA and BA are going to remain same. Similarly, PB and VB are going to remain same. But suppose we replace this adiabatic wall with diathermic wall after some time, because we have permitted the energy transfer both ways. In diathermic wall, we will observe the PA and VA will change, PB and VB will change, and now PA, VA you might say will change to P dash A and V dash A. PB might change to P dash B and V dash B, and after some time both the systems A and B are said to be in thermal equilibrium. So now, what is the unique characterizing feature of thermodynamic equilibrium? On close observations, it is found two systems are said to be in thermodynamic equilibrium if they have same temperature, that is T. So we can say if initially TA was the temperature of system A and TB was the temperature of system B, after some time when A and B have achieved thermal equilibrium, TA will be equal to TB. Right? Let's go further. So now we talk about the last concept to be learned today, that is Zeroth Law of Thermodynamics. It was stated by a scientist known as Fowler. And interestingly, students, one might wonder why it is known as Zeroth Law. I'll tell you. The first law of thermodynamics was already defined. And after that, this great guy observed that there is a more basic law than the law which is already defined, known as first law of thermodynamics. Since it was already defined, he could not name it as second law, because this law he thought should have come prior to first law of thermodynamics. Students must understand this law prior to first law of understanding, hence 0 comes before 1. He named this law as zeroth law of thermodynamics. This was the reason. Now, what is this law? Well, he says two systems are in thermal equilibrium with a third system separately. Once again, two systems are in thermal equilibrium with a third system separately are in thermal equilibrium with each other. Two systems are in thermal equilibrium with the third system separately are in thermal equilibrium with each other. So, see this? There's an illustration for this law. So, let's say, students, we have one system A. Okay. Now, system A, let's say, is in thermal equilibrium with another system, and system B is also in thermal equilibrium with other system. Well, that is possible only As we have just seen, if they are separated by diathermic walls. So this is another system C. C, right? There's some system C, right? This system C, A is in, this is diathermic wall. System A is in thermodynamic equilibrium with system C. System B is also in thermodynamic equilibrium with system C. And these both are separated by, let's say, adiabatic wall. Adiabatic wall. Students, if system A is in thermodynamic equilibrium with system C, system B is also in thermodynamic equilibrium with system C. If you remove this adiabatic wall and replace it with a diathermic wall like this, you will observe that the thermodynamic variables of system A and system B are not changing. In last case, the thermodynamic variables of system A and system B were changing because they were not in thermal equilibrium. Thermodynamic variables of system A and system B are not changing, they are same. That means system A and system B are also in what? Thermodynamic equilibrium with each other. Now students, I end this lecture here, giving you a small assignment. You have seen a thermometer. Thermometer exactly works on zeroth law of thermodynamics. Think how? I'm talking about a thermometer, not infrared thermometer, but a thermometer which has Hg. When you put it in your mouth, the mercury level rises. So which are the two bodies which are in thermal equilibrium with the third body? And then we make a judgment that these two bodies are also in thermodynamic equilibrium with each other. I wish you all the best. This is your small thinking assignment I have given you. Don't forget to subscribe our channel Learn CBSE to learn more and enjoy physics. Wish you all the best. Have a nice time. Tomorrow we'll discuss the work done and other things in different thermodynamic processes. Bye.